Al Turkey environmental consulting firm, AES International Consultants in the capacity of Business Development Director. He has a Master's of Engineering degree in Civil Engineering from Texas A&M University in USA, and also attended Executive MBA program at McGill University in Canada. Thank you, Mr. Nabil. Now, Mr. Nabil, your time to speak and share your valuable experience. So, Nabil, now your time. Okay. Go ahead, please.
Thank you very much, Dr. Saidor, and it's a real honor of mine to have this opportunity to speak to the students. And I would like to thank PMU and the American Society of Civil Engineers. And civil engineering actually is dear to my heart. As Dr. Saidor has mentioned, that I have a master's in civil engineering from Texas A&M University, and it really provided a broad platform for me to have a beautiful and wonderful career, starting off in Aramco with building the Aramco Exhibit Center, but then I entered very quickly back in the late 80s into constructing wastewater treatment plants for Saudi Aramco and these sort of things. So civil engineering is a wonderful foundation. Great. So can everybody hear me clearly? I hope the sound is fine. I assume so. Great. Okay, wonderful. Well, let's dive in right away. Great. So first of all, I send you greetings from cold Montreal. So it's really beautiful how we can have these communications and share the knowledge and share the experience. And this is really part of the circular economy in the sense that we have an opportunity to connect with each other. Great. So today's presentation, it will be a general introduction into circular economy, and it will follow the outline presented here. We'll talk about the linear economy versus the circular economy. Then we'll delve into some more depth about the circular economy. After that, we'll give two examples of circular economy, one of them touching on asphalt rubber pavement and the other issue dealing with plastics. Okay, so we'll proceed. So the circular economy, basically, it's a departure from the linear economy, which is a take, make, waste, production, and consumption model. Basically, as we know, traditionally, whenever, let's say, an item is going to be fabricated, whether it's a sofa set, whether it's a television or anything, the idea is that raw materials are extracted and a production takes place. Then this is distributed to the sellers, and then it is used, and then it ends up in a landfill and like in a waste. So this is a kind of a linear philosophy. Now the world is embracing a circular kind of an aspect to this. What does this mean? It means that at the end of the life cycle, there isn't really waste, but it is a raw material to be used once again in the production of items. And why is this significant? This is significant because we're trying to minimize the impact of environmental degradation and things like that, and also to minimize the utilization of the resources once again. What this also means is that we have to look at the full cycle. It means that the design of the items themselves need to be such that they could be disassembled at the end of their life cycle. And a very good example of this that presented to me is at IKEA, for instance. We all know that it makes furniture, and at the end of its life cycle, IKEA right now has a projection to be, I believe, something like 80 or 90% circular within 10 years, meaning that their products, they could be disassembled and then they could be once again put back as raw material to make the furniture once again. And there are other industries that are embracing this. Another is Interface. Interface is one of the largest manufacturers of floor tiling. At the end of the life cycle, rather than these floor tiles being sent to a landfill, the fabrics are disassembled and they're once again used as a raw material for that. So that's the basic concept of the circular economy. And to share with you, Accenture, which is one of the major consulting companies in the world, has said that the circular economy will be worth $4.5 trillion in the next 15 years. This is a phenomenal number. I mean, the question is this a valid number? But I think the main thing is the magnitude of the number. We're talking trillions of dollars. So there's a structural shift which is being done in the world. Okay, let's go to the next slide. And here I'd like to touch upon a subset of the circular economy, which is the circular carbon economy. What is this? Basically, the circular carbon economy, it's based on carbon-containing products, including elemental carbon, natural products, and petrochemicals, including plastics. The circular carbon economy is particularly significant to the energy-producing countries such as Saudi Arabia. And we could see that for many countries, products based on oil and natural gas are of very great importance. Hydrocarbons fuels generate greenhouse gases upon combustion. Now, there are worldwide efforts underway to store and utilize these gases, aiming to meet the circular economy concept. So what does that mean? It means that whenever we are utilizing and extracting hydrocarbons, there is a waste stream which is generated. It would be the emissions. These, rather than just being a waste, can actually be stored. They could be utilized for these emissions. They could be utilized for curing concrete. They could be utilized for fabrication of items. So the whole idea is to manage those emissions and have them for beneficial use, or at least to store them in a environmentally safe place, or to use them for reinjection for hydrocarbon production. And on this particular note, I would like to share with you all that, as we all know, Saudi Arabia recently hosted the G20 event in November. G20 is the grouping of the 20 largest economies in the world, and what the energy ministers of the G20 agreed is that they have endorsed the circular carbon economy platform as a tool to manage emissions and foster access to energy. The G20 energy ministers acknowledge the circular carbon economy approach as a holistic, integrative, inclusive, and pragmatic approach to managing emissions that aim to provide new pathways toward economic growth. So this is very significant, and this is on a global scale. Also, the United Nations Sustainable Development Goals have been conceived to ensure a sustainable future for the world and reflect the circular economy concept. And they include a call for substantial reduction in waste generation through prevention, reduction, recycling, and reuse, with the widely used logos we see on the right-hand side. So let's talk specifically now about Saudi Arabia. As we know, it has a significant population and growing. There is population growth, urbanization, and industrialization. And the volume of waste right now is reaching 1.7 kilograms per day per person. And plastics is a major component of this waste. Saudi Arabia still predominantly manages waste by dumping at landfills with only a 10% recycling rate. These landfills have a negative impact on the environment and contribute to land contamination, degradation, and greenhouse gas emissions. And the exciting aspect is that under the vision of 2030, an ambitious roadmap for a diverse, thriving, and sustainable nation is presented. This vision put forward in motion the kingdom's transition toward an environmentally conscious economy, and it focuses on preserving natural resources, increasing the efficient management of waste, enhancing recycling, reducing pollution, and also fighting desertification. So Within all of this, we see that a transition to a circular economy will help Saudi Arabia address waste management and help create a more resilient economic model that is not solely dependent on the oil sector. We see many wonderful mega projects being taking place in Saudi Arabia, whether they are the NEOM on the Red Sea projects. Throughout the kingdom, there's a lot of very exciting mega projects being done right now. And all of these will be including an umbrella of sustainability within them. And these jobs will be created across industrial sectors through increased innovation, entrepreneurship, and by a new service-based economy. This aspect of the new service-based economy is quite interesting thing to me. I think that traditionally, people, will always have, cars, they buy cars, this and that, but I think there will be a move toward more of a service-based economy where there could be more utilizing a car on a rental basis more than a ownership basis. Of course, there will be a mix of that, but that's something that's going to be coming up, and I believe that nations will have more introduction of efficient public transport that serves the needs of everyone. Okay, moving along. And the circular economy is going to create green jobs. It will generate revenue and value from recycling and reduce consumption of natural resources and greenhouse gases. These green jobs are positions in industry, agriculture, R&D, administrative and service activities aimed at preserving and restoring environmental quality. Great. The next part of the presentation, I will delve into the asphalt over pavement, which is a concept that falls under the umbrella of the circular economy. This is a very dear initiative to my heart because my last year in Saudi Aramco, I was based in the Western region, and we were very much involved in an initiative to introduce asphalt over pavement. So one of the first things that truly amazed me is that, and if you could imagine, every year approximately 20 million used tires are generated in the kingdom. Every year there's 20 million waste tires. This is a phenomenal number. And this great number of tires, it presents an enormous waste management challenge because, as you know, these tires, when they're dumped in landfills, you could have vectors and mosquitoes breeding in these because when water goes inside them and they stagnate. So it's a very unsafe situation. If they're burned, you have emissions. So and there could be leaching down into the groundwater. So it's a really significant environmental hazard. Now, however, with that, here's an opportunity. The opportunity is to use the crumb rubber of the tires for part of the binder in the roads. So what is crumb rubber? Crumb rubber is basically, it's derived from the scrap tires, and they're like granules which are generated from the process which includes grinding of these and extracting out the steel and the fabric from the tires. So from these, you could get this crumb rubber, and this can actually be utilized as a component of the roads. So what are we doing here? We're basically minimizing a environmental potential, which is these tires that would go into the landfill, and also we are reducing the amount of bitumen which has to be fabricated by the refining process also. So it has multiple benefits. And so what is asphalt over pavement? It's a special type of asphaltic paving material in which more than 15% of the binder content is crumb rubber from recycled waste tires. These asphalt over pavement has been started about 40 years ago, significantly in the US, in Arizona, and it's taken traction in California, in Louisiana, and so it's a technology which has been under development for quite some time, and it is being used in the USA and in parts of Europe. However, in the GCC and Saudi Arabia, these pavements have not yet been tried before. There has been crumb rubber that has been used, but however, it's been limited to low content asphalt modification, such as to improve the road asphalt rheology, which means the plastic performance of the roads. So what are the environmental benefits of asphalt rubber? I know I touched upon them briefly, but we could recapture it here. Asphalt rubber pavement minimizes scrap tires, thereby reducing tire stockpiles that are breeding grounds for a variety of pests such as mosquitoes. Also, used tires are a prime component of illegal dumping and a source of air pollution when burned. So here I'll talk a little bit about that pilot project which we did in Jeddah. We basically constructed a roadway section which is 160 meters long, 5 meters wide, and 7 centimeters thick. And this road right now will be monitored over the next year to see the performance, how trucks and cars run on top of it. And hopefully we will get positive results. This slide here, it talks about how the asphalt mixture was actually produced. The asphalt mixture was produced using an innovative modified dry mix method that has never been tried previously on a large-scale model. A little bit of technicality about this. This method eliminates the pre-blending and conveying of an asphalt rubber blend, as the crumb rubber was added directly into the hot mix asphalt plant. And the pilot itself, meaning the laying of the asphalt, it was a success. The paving mix was manufactured within the design boundaries. The transportation ran smoothly, and the laying, rolling, and finishing was completed without complications. As I said earlier, this section will be monitored throughout the summer to ensure performance and durability during extreme weathers. And then hopefully, upon successful observation and monitoring and testing, because we will have to take samples of the road during this time, the plans would then be to expand the deployment of larger asphalt rubber pavement projects and establish the foundation of a greener pavement industry in the region. And so from a technical mechanical aspect, what are the benefits of asphalt rubber pavement? Basically, they provide better resistance to permanent deformation. This means, you know, like when you're driving on the road, sometimes you see and you feel that there's a depression. These are these deformations. Also, there's better resistance to oxidation, which means there's less cracking of the roads. Also, they're safer because they make more friction between the road and the tires, which produce shorter stopping distances, reducing the risk of sliding and slipping. Also, they are quieter than conventional asphalt, thus reducing sound pollution. What is a technical challenge of this? One of the challenges is that the high content of crumb rubber makes the binder much more viscous than conventional bitumen, and this makes it difficult to handle with conventional mixing equipment, which means that there would need to be an introduction of customized equipment for this particular purpose. Great. So now we'll proceed into the other aspect of circular economy, which is plastics. Plastics is a very, very global issue. So plastics are the second highest volume of municipal waste produced in Saudi Arabia. And really, these plastics, they need to be redesigned to ensure that there is no product end of life. This involves restoration, reusing, repurposing, or recycling. By lightweighting packaging products, manufacturers decrease raw material consumption and transportation cost. This basically means you reduce the waste of the weight of the plastic. And to be part of the circular economy, it is essential for packaging producers to select renewable, recyclable, and non-hazardous materials. What does renewable packaging mean? It means that the raw materials used to create the packaging are derived from a natural resources such as wood pulp. Plastic converters, talking more about plastics right now, plastic converters are now exploring new bio-based materials that allow for packaging to enter the consumable cycle and safely feed back into the ecosystem. In case of renewables or bio-based materials, it is important to secure sustainable sourcing so that renewable materials extracted from the environment are replenished. This can be done through chain of custody certified sustainable forests or farms, which basically means, like, to me, and I remember when I took some executive MBA classes at McGill in Montreal, and one of the presentations was about Starbucks, how they were ensuring that the beans that they were getting to make their coffee, I think it was in Guatemala, they were working with the farmers to ensure that they were harvesting at the right time. They were not using, you know, pesticides or any kind of unhealthy chemicals added. So basically, you want to ensure that the source of where you're getting the raw material from, and you are working with the people there to ensure that they have a livelihood that is sustainable and is not degrading their forests or their farms. You know, I know this is a global issue. I've recently been reading about how in I believe it's in Malaysia or Indonesia, they're doing a lot of burning of some trees in order to create palm oil, and this is creating a smog like never seen before over countries, so like over many borders. So anyway, whenever you're doing something, you have to think of the what we call them external costs. You know, so you need to ensure that the full cycle is circular and you're not extracting material from a location but creating another problem. Okay, continue along over here. So different types of waste require different kinds of recycling capabilities. For highly contaminated products and packaging that can't be reused, treated, or recycled, the circular economy presents waste to energy as the final solution for problematic waste. This is a very interesting bullet here. I would like to reread it. For highly contaminated products and packaging that can't be reused, treated or recycled, circular economy presents waste to energy as the final solution for problematic waste. I think maybe perhaps I would like to throw a question out to all of the students and attendees. What's the problems with waste to energy, and why is it the final solution? If it is a final solution, and if it's a good one or not, what's the issue with this? Maybe you could give this some thought, and then somebody can come back and we can elaborate on this point in the discussion. Okay, the building of recycling capabilities across the kingdom is the building block to Saudi Arabia's circular economy, and this includes materials recovery facilities, MRFs, where collected recyclables are separated for processing. And the whole aspect of the circular economy, it's a global initiative, and partnership is essential for the circular economy of plastics to really take off in the kingdom, but not just circular economy. In addition to partnering locally, it is of significance to partner with international associations working towards pushing the circular agenda globally. These partners will bring to the local sector international expertise and know-how and potential support on important recycling projects. So in other words, we're all in this together. The world is all working together, and there are pockets of knowledge everywhere. And I think it's fascinating how here I am in Montreal speaking to students in Saudi Arabia. And I see as among the participants, I'm very honored to have with us Dr. Axel Meissen. He's in Vancouver. And so it's fascinating how we can connect. I wanted to share something also that I had missed it earlier. There's a quote from one of the Accenture presentations. It says that Just as the steam engine powered the Industrial Revolution, and that's basically what happened at the turn of the century, digital is powering the circular revolution. So another question for everybody to think about: why and how is digital powering the circular revolution? Maybe somebody can give this some thought, and then we could have an expanded discussion on this. Okay, and I think we're reaching the conclusion over here. As Saudi Arabia moves forward with its Vision 2030 objective to enhance recycling capabilities, it has established the Saudi Investment Recycling Company, and this is a subsidiary of the Public Investment Fund, and the SIRC placed the circular economy as its main mechanism. So it's very interesting. If you go to their website, you'll see the big word circular economy. So we're saying SIRC aims to drive the circular economy by partnering with society, waste management sector players, and private sector companies. With that, I come to the conclusion of my presentation, of which significant content was utilized from the ETMA newsletter, contributions by Dr. Axel Meissen and by NABCO Shadi Radi. I hope the presentation has been informative, and looking forward to any discussions. Thank you.
Thank you very much, Nabil. It was very clear and very nice presentation. I hope students learn a lot. Okay. So we are very glad to have Dr. Meissen. Dr. Meissen is here. Dr. Meissen, can you open your camera, please? Dr. Meissen. So Dr. Meissen is well recognized, respected professor who was former president of Memorial University, Newfoundland, Canada. Dr. Meissen also professors in chemical engineering department, was professor in chemical engineering department, University of British Columbia. Also, he served as a dean. So, Dr. Meissen.
Well, good evening. Can you hear me?
Your voice is clear. Yeah.
Okay. Well, thank you very much for this kind introduction, and I'm glad to join this webinar from the Pacific coast of Canada. And I'd be happy to contribute to the discussion which we are about to have.
Great to have you with us, Dr. Meissen.
So I have a few questions, but before going to the question answer sessions, I would like to request our honorable chair, Dr. Andy. Dr. Andy, can you speak about the webinar, or Dr. Andy?
Hello.
Yes.
Good evening, everyone. Thank you, Dr. Chaudhary, for giving me time to just give a little introduction here. First thing first, on behalf of Prince Muhammad bin Fahad University, I would like to say thank you to Engineer Nabil Hijazi, and also I would like to extend my appreciation to Dr. Meissen for attending this important seminar for our student. For your information, in the near future, which is I think in the next academic year, we will offer explicit course called Sustainable Engineering and Civil Engineering. So circular economy is going to be part of important topics, and I'm hoping that we will go back to Engineer Nabil Hijazi and Dr. Axel Meissen to just participate in our course in the near future. And the other thing, we were hoping that we would like to extend our collaboration, not only like exchanging information, but also in developing proposal and doing collaborative research, as well as probably advising some of our students. Again, thank you for your time, for your availability, sharing your information, particularly to our future leader and engineer here in the kingdom, which is our student here. Okay, thank you.
Thank you very much, Dr. Andy.
Mm-hmm.
Okay, thank you very much, Dr. Andy. Okay, so I have a few questions. Students, you can open your microphone and speak, or you raise your hand. So I will open your line. Okay, please. But I have one question from our students. Ali Khadim. Okay, go ahead, please, Ali. Ali, go ahead. What is your
everyone.
question, Ali?
Thank you, Engineer Nabil, for explaining this presentation. I have a quick question regarding the asphalt. So what's the difference and the benefits of replacing conventional asphalt with gravel asphalt, and wouldn't it be costly to cover big lands, specifically here in Saudi Arabia? Thank you. That is my question.
Okay, most definitely. The first part of your question is that what is the benefit of utilizing the asphalt over pavement versus the conventional, correct? I assume. Okay.
Correct.
There are benefits on several fronts. There are environmental benefits to it, and there are also technical benefits. From the environmental side of it, as we shared, every year there's 20 million tires coming onto the unfortunately landfills or desert and so on. So it's a recurring waste product which has environmental issues, vectors, mosquitoes and so on. Also, it's a source of air pollution when they're burned, and so environmentally, that's an issue there, which is like a health aspect. And also from the technical aspect of it, what do these roads provide? I mean, when you're using crown rubber with the proper mixtures and so on, these roads are actually, I'll go to the slide where we talked here about what are the mechanical benefits of it. They actually reduce the road deformation and the cracking, and they're safer because there's more traction with the vehicles and on the road themselves, and also they're quieter. So there are benefits from that aspect of it too. Now, the main thing is that in order for this industry to be introduced, it cannot be taken in isolation. There needs to be legislation which is implemented to mandate this. There also needs to be basic infrastructure that needs to be, like collection areas need to be put there in order to collect the tires. So really, it's something that takes multiple stakeholders. So it's not something that happens overnight. Technically, it works, but it will require the Ministry of Transport to be on board. It will require also that there are companies that have the proper equipment. As we shared, it's not like the regular company that does the road asphalting right now. No, they need to have specialized equipment for it. So it's an all-embracing aspect, but definitely it's proven to be successful in California. A significant number of roads are placed there in Louisiana, but a number of factors have to be in place for it to be a success, and it can be, but a number of factors have to be factored in. I hope that answers your question.
So can I add something to this?
Please.
Okay, so there are really two questions I want to raise for the students and for all of us to think about. The first one is, since the use of rubber has been demonstrated in the United States, in California and Arizona, why is it necessary to have a demonstration in Saudi Arabia? What do we need to discover by having a demonstration project? So that's the first question. The second question relates to, is rubber asphalt a circular product? It certainly uses rubber from tires, but is the asphalt that contains rubber now a circular product? To answer that question, you really have to think about what happens at the end of life of this road. Can it be reused? Can it be recycled? Can it be repurposed? So maybe you'd like to think about these two questions. And there are good answers to those questions.
Yes, thank you very
but you
much.
need to think about them.
And thank you very much, Dr. Myson. And I see here the opportunity of you know, uh, projects for students to research this, because this is a very good thing, very good question. Wonderful. Okay, I think we can go on to the next question.
Moving forward, okay. I have one more question from one of our students, Osama. Osama, can you forward your questions? Can you speak? You can speak, Osama.
Oh, yeah, sure, doctor.
Go ahead, please.
Yes,
First, you introduce yourself, and then questions. Please, go
okay.
ahead.
First of all, good evening. My name is Usama. My question was, does moving towards clean energy considered to be a part of circular economy, such as using electric cars and wind energy?
Okay. It's all definitely, well, okay, basically any production takes energy, so whether as we shared in the presentation itself, that I'll go back to the here. Yes, anything takes energy to be produced. Now, if the energy that is produced, that is being used to make the product, let's say it's wind power, or let's say it's water, hydroelectric power, something like that, then I believe we are closing the loop more, without a doubt. And what's very interesting, this morning I was reading in the Arab news itself that the CEO of Saudi Aramco had said that they are looking at renewables. So we're seeing the whole clean energy definitely is part of the mix. But if we look at, for instance, electric cars, that's a product, but the question always to be asked is, what was used to make the metal components of those cars? Was it wind power? Was it hydropower, or was it a combustible material? Dr. Myson, can you elaborate a bit on this?
Sure. I would say that clean energy is essential for the circular economy. And let me demonstrate this by means of the example that Dr. Hijazi gave, which relates to tires. The collection of tires requires energy. Very importantly, the separation of the components of the tires requires energy. To separate the rubber from the steel in the tires and from the nylon in the tires is a very energy intensive process. And it's in fact one of the large cost components in using rubber. Then the blending has to be done in a special way, as was stated in the seminar. That too requires energy. So energy is a critical component to enable the circular economy. We can have a separate discussion around where the energy comes from, but I think you need to take away from this seminar that to make the circular economy work for almost any product, certainly the ones that have been mentioned here today, and you can think of others, energy is essential. And if that energy doesn't come from sustainable sources, then the benefits of circularity will be much more limited.
Great. Thank you, Dr. Myson.
I have one more question from our one more student, Ali Tabit. Can you speak, Ali? Hello, Ali.
Yes.
Go ahead.
Yes,
What is your
good
question?
evening.
Good evening.
My question, I am Ali Thabit. My question is, after recycling, is the quality will be the same before, or it will be weak?
Of the road itself?
No, for the material, plastic.
Any well, very good question. It depends on what components are used from that, and if it does classify as a raw material. Like for instance, let's say for instance IKEA. If IKEA, as you know, like their chairs, they may have metal frames. So the idea is that at the end of the life, the metal itself, if it's been designed that it can then be the raw material for a new chair, and that metal component hasn't been compromised, then it does retain its its integrity, and so on. So of course, this is once again that the very interesting aspect of the circular economy is that you don't look at the end of the life just by itself, but you also, it enters into the design of products, and they need to be designed such that their end of life is used in a certain way. And this is what I find fascinating, is this aspect of why is this happening right now. And I believe, and Dr. Meissen, perhaps you could also elaborate on it, is that the digital is powering the circular economy. The question is how and why. Why, like 20 years ago, would we have been able to be talking about a circular economy with the strength that we have now? Dr. Meissen, can you please elaborate on the aspect of digital data and so on this?
Yes, so the availability of data is certainly important, particularly when it comes to determining performance. Recall what Mr. Hijazi said, rubber asphalts have been used as long as 40 and 50 years ago, well before the advent of the digital capabilities that we have today. So thanks to the digital capability, we can have data from many roads in many parts of the world, and we can look at the performance of this particular product. Since you are students of civil engineering, I would really like to encourage you to think about and to familiarize yourself how the quality of asphalt binders and asphalt pavements is determined. There is no single test for that. There are several tests, and rubber asphalt has to meet all of those tests. And if you look into this, you will see, or you will be able to conclude, why rubber asphalt is used primarily in warm regions of the world, like California and Arizona and Saudi Arabia, and not in cold regions of the world. We don't use it in Canada. And you might want to think about why that is the case. But to answer that question, you really need to look at how an asphalt road is made, what it consists of, what the different components, namely the binder and the aggregate, have to do and be capable to do in conjunction with each other under these different conditions of loads. So to come back to the initial part of the question, digital is important because it enables us to gather a lot of data, to analyze this data, and particularly analyze this data over long periods of time, because roads, I'll go back to this example, are meant to provide a service life of at least 20 years, and we are now striving for 30 and 40 years. So you have a lot of data that you have to sort out, and you can do this using digital means.
Great. Thank you very much, Dr. Meissen.
Okay, so I'm very glad to see a lot of brilliant questions coming from our student. I have one more for Ibrahim. Ibrahim, are you here, Ibrahim? Ibrahim, go ahead. Ibrahim.
Yes, sir. My name is Ibrahim, and my question was, is there any other building materials circular economy can produce other than asphalt rubber? That's
Is there any other building material that can be of circular economy? Well, definitely circular economy is it's basically a philosophy and a strategy, you know. So it's let me think about this. Because I was involved in the construction sector for many years. You could and what are the general waste streams that come out from a construction site, for instance? You have a lot of plywood, which is used for the formwork, you know. This plywood, does it have a use? I'm sure that this is a question that you know we can ask ourselves rather than it being dumped in the dump site. You know, this is one example. I don't know. So definitely, the circular economy is a strategy for what something can be used once again, can be reused. Dr. Meister, maybe you could elaborate a little bit on this.
Well, I was actually going to put the question to the students, what are other examples of the circular economy? But let me answer this question since you posed it. I think a really good example is steel. If you think about structural steel, when that is used on a bridge, for example, when the bridge comes to the end of its life, that steel can be recovered. It can be reworked, which typically means if it's not used as a steel member directly, but it can be melted down, it can be purified, and it can be cast into another steel component. May that be a member for a bridge, or may it be a rebar. So if you look at steel, it's actually an excellent example of a circular product. And even in the Saudi context, you have a company called Al Karan, I may not pronounce the name properly, I stand to be corrected, that collects metal and refines it, well, separates the metals, because the metals are often associated with other things like paint coverings or insulation materials, or sometimes other metals mixed in with it, copper. So they separate it out, and then they recover the steel, and they make new steel components. So steel is a really good example of the circular economy, and we've done this all around the world for decades. So there's nothing fundamentally new, although there are always refinements that occur.
Mm-hmm. Dr. Masson, thank you very much for sharing that. And that also, I remembered I had a discussion once recently with a gentleman in Texas, and he told me that a professor at Texas A&M University, he was keen on the circular economy, had engaged and made a contract with one of the car manufacturers. I believe it was maybe Ford car company. And Ford, when they make door panels, there's always some certain metal parts that are left over, and he actually used those to made a contract with them for a building for sunshades or something like that. So once again, we're talking about partnerships where somebody can have an innovative idea, and he's using the scrap metal from that's left over from making car doors, and they actually use them as a decorative shading element in a building. So there are, and once again, a phrase that was used in this presentation is innovation and entrepreneurship. So so it's up to your ingenuity to think of things.
So let me just, and that's a good example, let me just add to this and plant this idea into your minds. Metals are very well suited for the circular economy. On the other hand, plastics are not, at least not the plastics that we are currently producing on a very large scale commercially. And there's about a dozen plastics of different kinds that are being produced commercially. And none of them are particularly well suited for the circular economy. So I'd like you to think about why the difference. Why are metals well suited and why are plastics not well suited? And by the way, this doesn't depend on where the plastics come from, whether they are of a biological origin or of a petrochemical origin. It makes no difference. So I leave that thought with you, or that question with you.
Mm-hmm. Great. Thank you very much, Dr. Mason.
I have one more question from our one of our students, Hamida. Hamida, can you open your microphone and share your question, Hamida?
Yes. So my question is that can we consider the concrete that used in buildings or whatever to go under the circular economy as can be recycled?
Well, I believe the umbrella of the circular economy has the what we call the 3 R's: reuse, recycle, and what's the other one? So definitely, basically, whenever the concrete itself is reused once again, it falls under that aspect of reduce, reuse, and recycle. So yes, it's part under the umbrella of the circular economy.
But it's an example where the circle doesn't really close, right? So you make concrete, and at the end, you cannot use that concrete for exactly the same purpose that the original concrete was used for. But you can use it for other purposes. I mean, you can use the concrete and you can break it up, and you can put it, for example, into roads as aggregate, or you can put it into foundation fill. But then you can't use it again, right? So the basic idea of circularity is that the material that you have under consideration can go round and round and round. And in the case of steel, that's possible. You know, you can have that circle for the steel that I described to you. You can have it twice, 20 times, 50 times, 100 times. Now, each time you lose a little bit, but you can use it again. But you cannot do that with concrete. You can't do this with the conventional current plastics either. But closing the circle once, in the sense that you take your material and you make something else that's useful with it, that's a good idea. But it's really not a demonstration of what you might call complete circularity. And how do we get to complete circularity is a really basic question for which nobody has a good answer for many types of materials. And there lies a challenge for you as a new generation. You know, we've got to figure it out, and I'm sure we can figure it out. But it means doing things differently from what we do now.
Great. Thank you very much, Dr. Mason.
Thank you very much. Yeah. I have one more question from Othman. Please go ahead, Othman. Othman, kindly share your question, Othman.
Yes. Hello, my name is Othman Lawad. First of all, I would like to thank you for the good presentation. Well, my question is regarding the greenhouse gases and the uses that Saudi Arabia's factories and cars that we use right now, it hurt the environment, and wouldn't shifting from one energy source to another that is good for the environment be harmful for the economy in the upcoming years, since our economy is mainly focused on oil inside the country and outside the country? And wouldn't it be harmful for the individual, since it will cost the residential more money? Thank you.
Well, I think what we're touching upon here is the aspect of the circular carbon economy. And the objective here, and this is what the G20 has endorsed, is that to basically have to view like the emissions. They are a byproduct of the production of hydrocarbons, and the idea is that these emissions can also have a beneficial use. So once again, we need to, this touches upon technology, and once again, a very big aspect of the circular carbon economy is the introduction of technologies, as Dr. Meissen has indicated too. So whether these emissions, they could be used to cure concrete, whether they could be used for particular enhancing the circularity aspect. I don't know, Dr. Meissen, can you elaborate a little bit further on this point?
I think I will try. It's a really good question, and you raised the question of whether shifting energy sources so that there are less greenhouse gas emissions. You indicate that that's good for the environment, but maybe not good for the economy, I think is the essence of your point. And both is true, but it's only true in the sense that if we continue to use our hydrocarbon resources in Saudi Arabia, which are oil and gas, in order to make energy products. If we use the hydrocarbon resources to make other products that are not energy products, and therefore do not involve the generation of greenhouse gases, then the picture changes. And it raises a very important question. What would these products be? And would they support an economy that is as strong as the current economy, which is based on energy? I think the answer to that question is yes, but not immediately. And there will be a transition. I draw your attention to the changes that are happening in big companies like BP and Shell, which will remain energy companies, but the energy not coming from hydrocarbon resources in the long term. Okay. Now there are other companies that are involved in the hydrocarbon energy business right now that will take a different route. They will not be energy companies in the future, but they will be material companies. They will make things from oil and gas that are not energy products. What these products will be, how they will be produced, remains to be seen. But the very large market areas for materials and similar things that can be made from oil and gas while being compliant with the circularity concept. And that's what diversification, which is envisaged under Vision 2030, is to a large extent about. So try and think this through. Nobody has the absolutely perfect answers. These are questions that are raised around the boardroom tables of the largest companies in the world. And I'm sure Aramco is thinking about it, SABIC is thinking about it, BP and Shell are thinking about it, Total is thinking about it. And you as students today, you will play a critical role in conceptualizing the solutions to these questions and then implementing them.
Thank you very much, Dr. Meissen. Very thought-provoking and leadership thought. Thank you very much.
I have lots of questions coming, so it will take more time. It's okay, right, if I extend the discussions?
I can be here for another 15 minutes, but that's my limit.
So I'm very glad to see a lot of good questions coming from our students. I'm happy to see that. I have one more question from Muhammad Al Khalifa. Can you, Muhammad, can you highlight your question, please? Muhammad?
Yes, can you hear me?
Okay, what, can you highlight your question, please? Go ahead.
Yes, this is Muhammad Al Khalifa speaking, and my question is: if the logic of the circular economy is so compelling, why aren't more companies doing it already? Thank you.
If I understand your question is, if the circular economy is what it is, why are not more companies embracing it? That's your question? Okay, I'll answer that question. Yes, basically, everything starts off with a journey, awareness, and these things. Like right now, IKEA they want to go maybe 100% circular within the next 10 years. Apple company, they've actually hired their sustainability officer. She was the head of the US EPA, so she's coming on board on this. So nations and countries are all moving towards this. So it's a process of education, awareness. I know that Scandinavian countries, Norway and these places, they're all gradually moving into it. So it's a process, and it has benefits, and we are seeing a significant growth in this sector. I hope that answers your question. But at the end of the day, it has to make economic sense. Absolutely. I think it's important that if it doesn't make economic sense, it's not going to happen. So a number of factors need to be on the ground for this to take place. And this definitely requires legislation to enable this. And if I'm not mistaken, I think perhaps Dr. Meissen, you could talk briefly to this point. I believe that in Europe, vehicles are now, I think there's a certain legislation which is saying by the year 2030, I don't know, like 50% or 30% of all car parts need to be from the circular economy. Can you touch upon that briefly, Dr. Meissen?
Yes. So the European Union has a legal instrument which is called a directive. So collectively, the European countries put forward directives which are then enacted at the national level. And the directive regarding automobiles says that as of 2020, if memory serves me correctly, it's not 2030, 80% of all new cars have to be recyclable. Okay, so this does not apply cars that were made in the 2000s or 10 years ago, but on a go-forward basis, 80% has to be recyclable, and they have to be recycled. It's not just a matter of saying it's possible to do it, but you actually have to do it. So legislation and regulations play a very important role in answering the question, why aren't companies doing it? So the automobile manufacturers are obviously looking at it. And Mr. Nabil quite properly pointed to economics as being another factor. Generally speaking, it is cheaper to use what's typically called a virgin or an original raw material to make something than to use a recycled material. It's not always true, but in most cases, that's true. He also mentioned consumer attitudes, and IKEA is trying to capitalize on that because they feel that their consumers either want to buy furniture and similar household goods that are part of the circular economy, or they think that in the future their customers would want that. And they will particularly choose IKEA products over other products for that reason. But I think there is another factor that you really have to bear in mind, and that is to make the circular economy work. Technology is missing in most parts. I mean, for example, we do not have a good technology in order to separate different types of plastics. It just doesn't exist at this point in time. There also isn't good technology to make different types of plastics. It doesn't exist. We don't have good technology to take components apart. If you think, for example, of an airplane that has reached the end of its life, and let's suppose it's a relatively modern airplane, so it has a lot of composite materials in it, composites of glass or carbon fibers and polymeric materials. We do not have good technology to decompose those composites into their original components and to use those original components. So technology needs to be developed. And that's, again, a very important role for you as the next generation of engineers to think about.
Great. Thank you very much, Dr. Maisen.
I have one more question from one of our students, Zainab. Zainab, can you highlight your question, Zainab? Hello, Zainab. Zainab, are you here, Zainab? Yes, Zainab, can you highlight your question? Can you speak up? Can you speak?
I read her. Yeah.
Will the high temperature of Saudi Arabia affect the rubber asphalt, since rubber shrink when heated?
Definitely, a component is to test this rubber or these roads under various conditions, whether they are under high heat, under low heat, under moderate heat. So this is what's happening right now with these pilots, and the results will prove what the outcome is. And I believe Dr. Maisen had talked about how a road needs to be tested for various temperatures, on variances, because the same road would be subjected to high heat, high cold, low heat, and the temperature variance. So this is something which is ongoing, which is in a testing mode right now, and we'll be seeing the results of this. Something that I had a discussion yesterday with a colleague in the States. He said that, I was a bit amazed that we don't just want to test it for a year or two. It could be maybe it needs to be tested for several years, even up to 10 years. Who knows? But an interesting point is that now with this digitization, you could actually test a road with certain loads and compress the duration, rather than like 3 or 4 years, make it into like 9 months, and continuously have some hydraulic applications on that road. So getting back to your question, this is still under testing right now and under the conditions.
Well, I go back and encourage the students to take a look at what an asphalt road actually consists of, right? So in the very simplest of terms, it consists of layers, and each layer is a mixture of an asphalt binder and an aggregate. And the aggregate is like gravel. Okay, the asphalt binder basically holds the aggregate together. You can think of it as a glue. Now, the asphalt binder that is used without any rubber is not a single chemical. It's a mixture of chemicals that are obtained typically by the distillation of petroleum and they are the components that you get from the distillation that are the viscous high boiling point components. And you add the rubber to those components in order to make the asphalt rubber binder. Now you have the ability to change the composition of the petroleum fraction by using different petroleum sources and by using different distillation techniques. So you have considerable flexibility over the properties of the asphalt binder that you make by choosing the right petroleum fraction in any one case. And for hot regions like Saudi Arabia, you're looking for petroleum fractions that have high softening points, high softening temperatures. As opposed to in Canada, for example, we are looking for asphalt binders that have different softening temperatures. Now, there are many tests, and again, as civil engineers, you should look into this. There are many tests in order to determine in the laboratory the performance of binders and asphalt roads. And these tests are actually quite good to predict the longer term performance of roads. They are certainly very good to predict the performance of a road over a 5-year period. Many of the standard tests are not so good to predict the performance of a road over 10 years. And there are few that are good at predicting the performance of a road over 20 years. And that's why you need field trials. And there are lots of field trials going on and have been going on in the United States and in Canada and other countries, probably in Saudi Arabia too, since the 1950s. So we have information, lots of information on the performance of roads over a long period of time. So to answer your question very specifically, you can tailor, by choosing the right petroleum fraction, you can tailor the properties of your asphalt binder before the rubber crumb is added to it. And you can test that both in the lab, and I'm sure that Aramco has done that before it built its test section of 160 meters. But ultimately, there is no replacement for field trials. You need to know that.
Thank you very much, Dr. Meissen.
We have a limited time, so hello.
Yeah, I unfortunately have another commitment.
We have limited time.
So,
thank you, Dr. Meissen,
I
for
have
your...
to.
Go ahead, please.
Yeah, so I have to excuse myself. Please carry on with the conversation. It was a pleasure hearing your really thoughtful questions, and I hope you will take some of the questions and answers outside the classroom, and some of you may even build a career around circularity products, which would be wonderful for you, and it would be great for the world. So I will sign off. Thanks very much.
Thank you very much, Dr. Meissen.
Yeah, we're very glad to have you today. Thank you very much. Yeah. So we have only.
Bye-bye.
We'll take only 2 more questions, okay? So one question's from FD. Go ahead, FD, quickly, and then Satam. Sorry, because we have time. We should have time. So FD, go ahead. What is your question?
Yeah, thank you, Engineer Nabil and Axel, for your time. I have a quick question. How we tested the asphalt rubber pavement needed to perform building roads, and its quality for this country. Thank you for your time.
Yes, yes. Well, the way it's tested is both visual and lab. So basically, the pilot has been laid, like the road is there, and then vehicles, trucks, and so on. So it becomes open to the general public traffic. So it's observed how it is deforming or not deforming. and also core samples are taken at periodic places to see what the composition of the layer is itself, how it is performing. So it's both a lab and also a visual testing. Thank you.
Okay, we have last questions from Sattam. Can you what is your question, Sattam? Hello, Sattam.
Yes, how are you?
Go
Good
ahead.
evening, everyone. My name is Satam Mutwalli. I want to ask about the rubber road. How many times we can use it, reuse it again?
The rubber road itself, you mean at its end of life, you mean? Or, okay. Basically,
The end of life, yes.
Yeah, well, that's a factor. It's a good question. How long? Well, typically it will hold up. It's tested and it's used, and does it? If the performance is satisfactory, then it could be the same life as the actual road itself. But there's an interesting point that Dr. Meissen had talked about, is that in order for the full circularity to take place, because each road has an end of life to it, the question is that can those materials themselves then be reused and making a new road or making a different kind of road? So that's the question to be asked in order to complete the circularity. But these roads, they all have an end of life, whether it's 20 years or 30 years. This is what a typical road is.
One more question. What about the quality of the material? About the rubber road and the normal road, it's all the same time of life and same time of quality?
Yes, as a matter of fact, it's proven to be superior, because if we go to the slide that I had talked about here, where we talk about the mechanical properties of the in comparison. I'll go to the slide here. Or is it? No. Keep on going. From the mechanical properties of using, they are superior to conventional asphalt. How? In that they have better resistance to deformation, they provide less cracking, and they're safer and they're quieter. So yes, it has added benefits to it, actually, technically.
Okay, this
I hope that answers.
This is the end of our question answers period, and I'm sorry to say a lot of questions coming, and I'm glad to see a lot of good questions, and I hope I will refer to Mr. Nabil, and then he will answer it, and I will circulate all of you. It's okay, right? So I already know. I already noted a lot of questions from our students, and I will circulate to. I will refer to the engineer Nabil, and then he will answer it. As far as capacity, and I will share with my students.
Good. Well, Dr. Saidor and Dr. Andy and the students, I'd like to share with you that, as you know, I'm a director of ETMA, the Saudi Arabian section of the Air and Waste Management Association. And we're going to be convening Petro Environment 2021 in November. And a key focus of this conference is the youth engagement and participation. Maybe based upon this, presentation, we could have, I'm thinking creatively here, we could have a focused exploration, like there's like 6 more months leading up to this conference. Perhaps we could have the students develop some questions and research some answers, and then present something at that conference, because this will be a global conference. I think it would be very interesting to have ASCE Student Association at PMU present something about asphalt rubber pavement, their questions and their investigations. What do you think, Dr. Saidor?
That's great, yeah. And I'm very glad to be part of your environment. So I would like my student to get in, get involved with the different activities.
Dr.
And,
Saidu,
yes, go ahead.
I have a quick question for Engineer Nabil. Thank you, Dr. Engineer Nabil. And my question is, we know the foundation for normal asphalt, okay? It will be for the asphalt bubble. It will be the same or different? And thank you.
The specifications, no, the design mix has to be completely different because we're introducing crumb rubber into it. So it's important to have designers on board for this mix.
Okay, thank you, sir.
Your answer? Okay. Thank you very much. Okay. So I'm just really appreciate all my students.